temperature and thermal energy. Today's essential questions that you should be able to answer by the end of this lesson are: 1. What is temperature? 2. How are temperature and thermal energy related? When considering temperature and thermal energy, you need to keep in mind that these concepts are real-life applicable. Every day we use these two ideas. First of all, think about the temperature of food. It must be raised in order to cook, heat, or chemically change the food that we eat. Transportation must conduct thermal energy in some way to operate and move people from place to place. For example, in the cars, buses, planes, and trains that we use. So let's get started. First of all, the matter around you is made up of tiny particles that are in constant random motion. And because those particles are moving, they have kinetic energy. Let's consider solids. We'll look at a picture of an ice cube here. In liquids, we'll look at a glass of water. And then gases, we'll look at some steam that is rising from a geyser. All three states of matter are represented here: solids, liquids, and gases. Let's consider the particle arrangement in each. After looking at those particle arrangements, you probably noted that solids, liquids, and gases occur at very different temperatures. So first of all, what is temperature? The temperature of an object is the measure of the average kinetic energy of the particles in an object. Some basic things that you need to know about temperature include the measurement tool we use to measure temperature. That's usually a thermometer. The SI unit for temperature is Kelvin, represented by the symbol K. Other units that you are more familiar with when measuring temperature include Celsius, represented by degrees Celsius, and Fahrenheit, represented by degrees F, or degrees Fahrenheit. Now, let's put some ideas together. How do temperature and thermal energy relate to one another? Let's recall some facts. Now, recall that temperature is the measure of the average kinetic energy of the particles in an object. Think about this, though. Particles in matter also have potential energy. Which type of matter would have more potential energy, a gas or a solid? Now, let's consider what is thermal energy. Thermal energy is the sum of kinetic and potential energy of all the particles in an object. This is the thermal energy of an object. Now, let's think about this. Infer why increasing the temperature of an object also increases its thermal energy. Thermal energy depends on temperature and mass. For example, let's take 2 glasses of water. Glass A is half full, and glass B is completely full. Both glasses are at room temperature. However, the mass of glass A is less than the mass of glass B. Which of these glasses would you think have more thermal energy? If you guessed glass B, you would be correct. Even though the temperature is the same in both glasses, because glass B has more mass, it would contain more thermal energy. So again, thermal energy depends not only on temperature, but also on the mass of an object. Let's do some think aloud exercises. Consider a hot horseshoe and room temperature lemonade. Is the temperature higher or lower in the hot horseshoe compared to the lemonade? If you guessed higher, then you would be correct. Now let's consider thermal energy. Should thermal energy in the horseshoes or the lemonade be higher, the same, or lower? If you said higher, you are probably most accurate. However, you would be unable to determine completely considering that you do not know the mass of each of these objects. Usually horseshoes have more mass, thus it would probably have more thermal energy. However, if we're talking about masses of lemonade, then possibly the lemonade could have more thermal energy. But in this case, the hot horseshoe has a higher temperature and has a higher thermal energy. Let's consider two test tubes. Test tube A has slightly more green liquid than test tube B. Let's consider temperature. Do you think the temperature in test tube A is higher or lower than test tube B? If you said it probably doesn't matter, neither are higher nor lower than the other, then you are probably most accurate. Let's consider thermal energy. Do you think the thermal energy is higher, the same, or lower in test tube A than test tube B? If you said that test tube A has slightly more thermal energy than test tube B, you would be correct. As you can see, test tube A has more mass than test tube B. Therefore, test tube A would have more thermal energy. One more. Let's look at those test tubes again. Only this time, test tube A has a certain amount of liquid, and test tube B has the same amount of liquid. Is the temperature in each test tube higher or lower? If you said they're about the same, then you would be accurate. Let's consider thermal energy. Is the thermal energy in test tube A higher, the same, or lower than test tube B? If you said the same, then you would be correct. Each test tube appears to be at room temperature and also have the same amount in each. Thus, the thermal energy would be the same in each test tube. So let's review. The first question is, temperature is A, the sum of kinetic and potential